All right, let's take a peek at ARP, your Address Resolution Protocol. Now, ARP is very important. You need to know this. You need to know that it maps the IP address to the MAC address, as in your physical address of your network card. Now, an IP address, also should know, is a 32-bit software-assigned address. And again, with the 32 bits, we're talking about IPv4, okay, when it comes to IP address. So this is a decimal format, and it's 32 bits on the binary side. So we are able to do different things with that. Again, we'll talk more about that later as well. All right, it is, of course, here at the network layer, and we have the MAC address, which is, again, the physical address, and it's 48-bit hardwired into the network interface card. It is going to be at the data link layer, as in ARP is going to be running at the data link layer. All right, and the IP address itself, as you notice there, is going to be at the network layer. All right, anyways, so we have data link layer protocols. You need to understand MAC addresses, not IP addresses, okay? Meaning that ARP only understands the MAC address information. It just kind of maps the MAC to the IP. That's really all ARP really does, the Address Resolution Protocol. Now we also have what's called RARP, which is your Reverse Address Resolution Protocol, and it maps the MAC address to the IP address. So IP to MAC and MAC to IP, all right? That's how that all kind of comes into play. Now keep in mind, with ARP, let me show you here real quick. With, let's say if I use ARP and I do a ARP -A, that shows me my ARP cache. So you can see here, this is all my information regarding my IP address, the MAC address, right? And ARP keeps track of that. Now, what I can do is I can type in something like ARP -D that will delete my ARP cache. And now if I do an ARP -A again, you'll notice here I have no ARP entries, which is great, because that means I don't have any entries right now. So whenever a machine goes out there and says, hey, what IP address is this? All the machines in the network will basically pick that up, put it in an ARP cache, and say, okay, so-and-so MAC address is this IP address. And so as the entries go through the network, everybody picks it up, and then the one that has it responds, and then everybody puts it in their ARP cache. And that's how you end up with a lot of entries in your ARP cache. Now, the interesting thing with ARP cache is that it can be poisoned for an attack known as the man-in-the-middle attack. For that to be successful, we need to do some ARP cache poisoning. And then once we do ARP cache poisoning, we also have the ability to do DNS cache poisoning, which means on the DNS side, which maps the host name, or your fully qualified domain name, such as www.google.com, to an IP address. And we can also manipulate that as well with a different attack called DNS spoofing or DNS cache poisoning. And again, this is all part of the man-in-the-middle attack type scenarios. So ARP is definitely very important, and we need to keep track of that. Now, another way where ARP comes into play is going to be with switches. And not necessarily ARP, but more the relationship between MAC address and port numbers. So when it comes to a switch, for instance, we also get into things where it keeps track, a switch will keep track of the IP address to what port number, and of course the MAC address information as well. So we have MAC, IP address information, and then on what port. So that way it keeps track of the information coming in through a specific port number. Now, I mentioned here a few moments ago the CSMA, your carrier sense multiple access, and then we have collision detection. Now, collision detection generally is going to be in a hubbed environment where you have data just getting sent out onto the network. There's a lot of collisions that happen, and on your hub, for instance, you'll see a lot of red lights or orange lights or yellow lights, and those basically indicate collisions on the network. Now, with a switch, we basically are putting in what we call the carrier sense multiple access collision avoidance. And basically what it does, it keeps track of what information is coming through what port, as in what client it's coming from and so forth, and it's able to control the traffic so there's not a collisions happening on the network. So it's kind of like a traffic cop in a sense. It keeps track of all the data going through and so forth. When it comes to a switch, we basically have the ability to override that switch and make it act like a hub. And the way we do that is we force MAC address to IP pairings to the switch. The switch has what's called a CAM table, content addressable memory table, and it basically keeps track of your MAC address to IP address to where the port, what port it's on. And that can be manipulated by a tool called MACOF, M-A-C-O-F, and it basically floods the switch with literally thousands and thousands of entries for MAC to IP pairings, so that the switch can then basically come back and be overwhelmed and cause that CAM table to fill up, which then allows that switch to act like a hub, which allows us to then see everything on the network instead of just the section that we're connected to. Now, in the terminology that we've used before when it comes to reconnaissance and so forth, it's definitely one way to go to get additional information about the network. As we'll talk later about sniffing, this would be considered active sniffing whenever we're connected to a network with a switch involved. It's always considered active sniffing. All right, and we'll talk more about that in the sniffing module here later on. All right, so anyhow, that's where all that kind of comes in. I'm going to repeat some of that again because it is very important to remember the differences between that, but there you have it. All right, let's take a peek at ICMP. Now, your Internet Message Control Protocol basically allows you to have status and error messaging protocol. That's not used to move user data. However, you have the ability to actually move data inside of it, which is a different type of attack that we can use. But for that, you probably want to check out some of the ICMP RFCs, your request for comments for that. Another place to go to real quickly too for your scenarios here. Let me give you guys a scenario here. What you can do is go to protocols, protocols.com, for instance, and from here, look up TCP/IP. So you look up TCP/IP, and then from here, you can look up ICMP. And as you can see here, it's running RFCs, your request for comments, 792 and 950 that you can check out. But here's what's really important is this type and this code, because you will need to know certain type and codes for ICMP. And what I would recommend is that you go through and memorize a few of these, because you never know what may come up when it comes to that. But as it's mentioned here in the slide, is it does give us status error messaging, and we need to pay attention to that, as in what type and code it comes up with, so we can then identify what's happening. All right, the ping utility uses this protocol. Right, so when you do a ping to a specific IP address or a name, obviously it's going to come back, and ICMP requests are sent, and ICMP replies are also sent as well. Now, the way ICMP is used by hackers, although it's allowed through most firewalls, it's used for host enumeration. It can redirect traffic by sending bogus ICMP messages to the router. The router then thinks that another router is telling it that a link is down or congested. And as I mentioned before, you do have the ability using other tools like HPing, hyperping, to actually take, for instance, an Excel spreadsheet and dissect it into the ICMP requests that are going out when you do the ping, and so forth. But we won't talk about that right now too much. Maybe we'll mention it later on, but just know there are definitely some possibilities there. Pretty cool stuff. All right, let's take a peek at your network services. And this is going to be your DNS server, right? Domain name service server. And it works in a hierarchical naming structure. We have host name to IP address mapping. Again, this is going to be your name to IP mapping. And the DNS server that holds the resource records for a zone is called the authoritative DNS server for that zone. And overall, when we talk about zone transfers, it's a pretty simple concept. Basically, what we're doing is we have multiple DNS servers. And we can do what's called a zone transfer from one DNS server to another, or to a client machine that's requesting it. And it just gives us additional information. I'll show you guys some tools here that will allow us to do some zone transfers. One is called DNS enum, and the other one is called NS lookup. Now, we can also use another tool, which is in the Unix-specific world called DIG. And it allows us also to enumerate some of the DNS servers out there. Now, for this to work properly, we need to have port 53 open, and so forth with that. All right, so keep that in mind. Port 53 DNS allows us to do zone transfers, and we'll take a peek into NS lookup, and then mention DIG, and again, use a tool called DNS enum that can be found in Backtrack in Kali as well, that you can then check out to do some DNS zone transferring with. Pretty cool. All right, then we have SNMP, your simple network management protocol. It basically runs off what's called a master and agent model. The agents gather status information about network devices, and the master polls the agent and provides an overall view of the network status. Now we have community strings. These are going to be default strings that we use, one called public and one called private. And so best thing there to do is to change that into something else. Public is for read-only, and private is for read and modify of your MIB data that can be used to modify it, depending on what community string you use. Now there's tools out there, so one called Look at LAN, for instance, that will allow us to go in. We'll take a peek at that. You can see what information can be extracted from that. Now there is also other information that can be used for SNMP data. There's one called SNMP check, also known as the SNMP enumerator, and it basically will also go out there and enumerate information from SNMP. Now it runs off port 161 and 162, but anytime you see it, it's going to be running off of 161. Now 162 is what's called the SNMP trap, but that runs off of 162. But the main one we need to remember is 161. All right, now when it comes down to SNMP, again, lots of information that can be leaked. Remember, version 3 is what should be used if you're trying to protect the data, because it will encrypt the information versus version 1 and version 2, which provides it in clear text. SMTP, your simple mail transfer protocol, transfers mail between different mail servers. SMTP is used to push information out, as in sending information. So a protocol sends outgoing mail from email clients, versus POP3, which is going to be used for receiving emails. Right? And then we also have IMAP. Now, SMTP runs on port 25, POP3 runs on port 110, and IMAP runs on port 143. All right, anyhow, we have security issues with mail servers, such as they're improperly configured as mail relay servers, which allows us, again, to send out unsolicited emails using your mail server. The server is identified and used by spammers, and companies get blacklisted by other companies without knowing why. Well, it's because they have port 25 open, right? And they have their server configured as a mail relay server. So that means that we can use it and abuse it and so forth. So no SMTP. We could also, for instance, with SMTP, if port 25 is open, we can telnet into it. We can telnet into that server with port 25, and then we could construct an email message from the command prompt and then also send that out unsolicited. Pretty cool stuff. Now we've talked about some of the different port numbers and so forth. We will be mentioning more port numbers that you're going to need to know, and we'll cover a few of the different protocols and services we just talked about. And here we're going to identify more so of those in the scanning live systems. Now here we're going to spend a little bit more time on, because you're going to need to know a lot of information regarding some of the tools that we're going to be using, especially a tool called Nmap, your network mapper. And my suggestion would be is to, one, pay attention, obviously, what we're talking about here. Secondly, is to look into using the Nmap tool yourself to see what some of the different scenarios are, what the output looks like, and things like that. All right, so here we go. You guys ready for this? Let's make it happen. All right, so here we get into introduction to port scanning. Now, scanning is a method for discovering exploitable communication channels. Port scanning here is how attackers identify open and available TCP/IP ports, services, and applications on a system. Did you know, just because we know the port number, we can identify what service is running, and depending on the type of switch we use with a particular program, we can also identify what version it's running. That's pretty awesome. So when it comes down to application services on the systems that are associated with well-known port numbers, again here the example we're giving is port 80 for HTTP, port 23 for Telnet, and port 25 for SMTP, which you should know these by heart already. If not, make sure you memorize them. So when we figure out what services run which ports, well, you can actually go online and check out the INA.org assignments port numbers, and it shows a list of well-known and registered port numbers. This is also the main references for port numbers as well. You can also check out a list of Trojans which run on certain ports by going to glocksoft.com/Trojan_port.htm. And you can go to neohapsis.com, neolabs, neoports, neoports HTML, And this site lists a combination of the two, both well-known and registered, and Trojan port numbers as well. So again, it is important to know port numbers. Now again, you don't need to remember 1,023 port numbers, but you will need to know a few, at least a dozen or two, to be able to identify quickly what it's running, and then with that, be able to answer certain questions correctly because you knew the correct port numbers. Okay, so some of the port scan tips: you should understand the three-way handshake. So as long as the three-way handshake has not been completed, the law generally hasn't been broken. Now, anytime we talk about not completing the three-way handshake, we can also identify it as a stealth scan or a SYN scan. And we'll talk more about those here in a little bit. All right, a port scan is also like checking to see if the door is unlocked, but not entering to see whether someone's at home. So no crime generally has been committed yet, so in most cases the police can't do anything at this point. So if a computer system is attacked many times by a port scan, one could possibly argue that the port scan was in fact a denial of service attack, which is usually an offense. So be very careful here. Laws differ in the different states and countries, so check with your legal department to make sure all is good to go. Now, as with anything else, of course, make sure if you're doing any type of scan like this that you have permission in writing to do so. Okay, port scans should reveal if a system is active and responsive, and of course what ports are open, closed, or even filtered. Now, what services are running and what information can be gleaned? We can figure out services and versions of those as well, which could then identify particularly like what version of Exchange it might be running, or what version of IIS you might be running, and things like that, which then tells us what the operating system and possibly the patch level that's running. A lot of times we can figure that out through the SNMP, your Simple Network Management Protocol. Port 161 can give us that information, again, using specific tools. And we can, of course, kind of get together a network blueprint overall and figure out, what they have on the network. So some popular port scanning tools. Again, here's a tool called Look at LAN, which allows us to do some really cool things. So we're actually going to show you these, and you get a little preview of what they look like and how they work. Again, if you have the opportunity, try them out, see what you think. Otherwise, just take my word for it, and as you're watching the video demos there, and see what you can do there. But Look at LAN is definitely a nice little tool used for, very popular for the SNMP enumeration. We have SuperScan, which can be used both for scanning as well as enumeration. We have Unicorn Scan. We have Nmap, which we'll be spending a little time on. We have another tool called AutoScan, and HPing2 and HPing3, which obviously you most likely will use the later versions of that. But again, very, very interesting and cool tools that you can use for that. All right, so check out some of these and take some notes. Okay, so hopefully you had an opportunity to check out the demo videos on each of these tools. Again, some are going to be more important than others, but at least now you have an idea of what the tools can be used for and how they can be utilized. When we're looking at ping, right, is the host online? We basically look at some basic network connectivity that can be tested using the ping command to determine the range of IP addresses mapped to the live host. Now, as was mentioned in the particular HPing demo, is at the end, sometimes you don't get a ping back. Because generally when you get a ping and then you get a reply, it tells you that the host is online, meaning that the host is alive and it's out there. But however, as we saw with the HPing demo, there towards the end, we can also identify a online machine, even though it's not replying to ICMP requests. We can still get some data from it, or at least identify it as being online. And that's generally something you want to do a lot of times with your firewalls and routers and so forth, is you maybe don't want to have them reply to a ICMP request, right, as in a ping request. And because once we identify it, we can then check out what ports are open and so forth. So sometimes, and as we'll mention here in some of the Nmap switches, we can actually still do a port scan on our system that doesn't come back to a ping, but we can do other scans to it and still get some information in regards to what ports are open. Right, so again here, the ping sends out ICMP echo request packets, and if the address is live, an ICMP echo reply message will be received from an active machine. Ultimately, you can have TCP and UDP packets, which can also be sent if your ICMP messages are blocked. Pretty cool stuff. So we have what's called stealth online ping, which basically allows us to ping another machine from another IP address. So here we're basically doing it from the centralops.net site, which allows us to basically go out there and ping another machine. And what then happens is as the machine that we're pinging comes back and identifies us as where we're pinging from, it actually is going to pick up the IP address of centralops.net and not our IP address that we used to ping from. So in general, we refer to that as a stealth online ping. Okay, now here we have the three-way handshake. Very important to know the order that it goes in. We have what's called the synchronized packet. And again, we'll talk about the different flags that we use when we're going out there and doing our thing. Now, with the synchronized packet, it's generally going to be the initialized packet that comes out. It sends a client sequence number along with it. It's to the server. The server responds, in this case, or it might be another machine, responds with a SYN server sequence number and an acknowledgement, and then it finishes it up, the three-way handshake, with the acknowledgement. So TCP connections begin with your system sending a SYN packet to the server. The SYN server responds with a SYN-ACK, and then your system responds with an acknowledgement, and the connection is established. Again, know the order of the three-way handshake.